let's get started. Welcome, everyone. Thank you so much for joining us today. My name is Jessica Rodriguez, and I'm the Industry Engagement and Outreach Officer for the Data Science Institute here at Columbia. Today's seminar is an iCubed, which stands for Institute, Industry, and Innovation. These seminars connect our industry affiliates to our students and to the larger Columbia community to explore topics at the forefront of industry. We invite data scientists, engineers, and researchers from our affiliate partners to give a talk about a recent project, case study, or the data science work they are engaged in. During these educational events, we encourage attendees to ask questions via the chat and Q&A feature. There will be Q&A time towards the end of the talk. Today's talk is titled Scalability and Innovation for the Global Customer in Health Markets and is brought to us by our industry affiliate, Elsevier. Today we have Elia Lima-Walton speaking. She is a physician informationist that has been with Elsevier since 2015. She went to medical school at the Universidad Autónoma de Guadalajara in Mexico and completed her medical studies at New York Medical College. In her current role as Director of Data Science and Clinical Analytics for Health, she leverages her knowledge and expertise in medicine, data science, and taxonomies to drive strategy in developing novel, scalable solutions to improve the clinical experience at the point of care, and also to support the students and researchers' journey. Her research interests include identification of semantic patterns from unstructured text, text mining, CDS, autonomic item generation, and knowledge graph expansion. A bit about today's talk. In this presentation, Dr. Lima-Walton will showcase what and how Elsevier works with research and the health science community to improve search, content access, identifying key resources, and help improve the patient care using data science technologies. We are also joined today by Anita Waard, VP of Research Collaborations, and Josh Fisher, data scientist, both from Elsevier. Thank you so much, and I hand over the reins to you.
Wonderful. So excited to be here. Thank you so much for inviting us, Jessica. And you were able to say Universidad Autónoma de Guadalajara with perfect accent.
Thank you.
Okay, let me go ahead and share my screen and just start to walk you through. Let me know if you could see my screen.
Yes, we're able to see. Yes, perfect. Now we're in presentation mode. Great.
Okay. Awesome. So what we're here to talk to you about today is a little bit about who we are at Elsevier, what do we work on, what is our mission, and what are some examples of data science projects in data science in general and also in data science health. So just to recap a little bit about us, what our mission, let me just try to move this out of the way. It's not, there we go. There we go. With our mission, Elsevier basically helps researchers, educators, professionals to advance science, to be able to improve evidence-based knowledge for the benefit of society. We're a global information analytics business, and we have a unique content set and technology that helps support operational efficiency. We do this both here in the United States and abroad. So we support our 5 main customer segments. We support clinicians by answering, have you thought of this different type of treatment for your patient? Researchers being able to answer questions, governments by providing answers on what to invest in, pharmaceutical companies in developing or discovering novel treatments, and also in medical and nursing students by being able to create different types of novel, innovative products that can actually help them with their education every step of the way. This is a quick view of some of our different flagship products. So I just want to highlight Osmosis is a new one that we acquired about a year ago. Also SharePath, these are educational products for students, nursing students, and medical students. And we see a couple of others over here like Scopus, Clinical Key, Science Direct, etc. We have over 250 total data scientists and clinician specialists. And we are all over the world. We truly are a global company. We have over 8,700 employees, and we have main hubs in Amsterdam, London, Philadelphia, Chennai, Bangalore. Our data science lab is at discoverylab.ai. You can take a view and see what sort of collaborations we have. We have a total of over 90 collaborations with different universities across the world. How do we operate? So now going more into data science health, who we are and how we operate. we have data scientists, domain, clinical, we have physician informaticists such as myself, nurse informaticists, localization experts, and we work really closely with other teams in a matrixed environment, forming squads. And what do those teams and squads form? We have strategists, product managers, and taxonomists as well. This is basically what we do is we work together to execute on innovative projects aligning with internal and also external collaborators. Again, this is a quick view of the different regions where we are represented. There are 3 main initiatives or capabilities that we work on in data science health. The first one is dealing with search, and this has to do with being able to improve concept alignment or taxonomy alignment for information retrieval. The second one is integration. So we work on developing different types of capabilities that can extract metadata, normalize it, and just pretty much create new technologies for different products. We also focus on globalization and localization, and this is really being able to adapt our different products to have the look and feel to the different cultures and segments. And so I will walk you through a bit of what that looks like in practice. But first, I wanted to talk to you a little bit about taxonomies and what is a taxonomy. So if we want to look at the definition, it's the science of identifying and naming species and arranging them into a classification. A simple one is what we see on the left side of the screen. So the animal kingdom, where we have the notion of mammals. Then from mammals, we go to felines, from felines, domestic cat or panthers, etc. That's a simple taxonomy. And why is a taxonomy useful? It provides structure. It allows information to be surfaced and normalized, and allows semantic patterns to be drawn between concepts. So in our case, it actually helps clinicians, researchers, and students to find actionable, concise answers. So I'm just going to tell you a little bit about Elsevier's medical taxonomy. It's a multilingual taxonomy that's available in English, French, Spanish, German, and Brazilian Portuguese. We're also we're working on a couple of pilots in Arabic, Chinese, Nepali, and Somali and Armenian. It's concept-based, meaning that all of the different concepts are identified and associated with a unique identifier called IMUI, which is stable. And it's also an ontology because not only is there the hierarchical dependencies between a parent and child, we also draw relationships between concepts such as symptoms of a disease, treatment procedures of a disease, complications, etc. It's explicitly mapped to international medical standards such as SNOMED-CT, ICD-10, LOINC, CVX, RX norm. And then we also map to Elsevier's internal vocabulary such as Gold Standard and the Dorland's Dictionary. It's continually curated by a team of clinical medical experts, and it's available via an API. And it really helps in powering our knowledge graph and to be able to identify and improve information retrieval at the point of care. We have over 400,000 medical concepts, over 1 million synonym labels, and over 220 semantic relationships that have been extracted using natural language processing and have been validated by clinician SMEs. If we look at the left side of the screen, we see the taxonomical component. We see there's a polyhierarchy. There are different parents, breast disorders, cancer of thorax, for the concept breast cancer. We also see that there's a unique identifier. There are different labels associated with each of the different synonyms. There's malignant tumor of the breast CA. And essentially what this does is it allows our concept mapper to be able to identify different types of concepts within documents when building an index to know that breast CA equals breast cancer, which also equals malignant tumor of the breast. All of the data is organized into semantic categories. In this case, it's neoplasm process or disease. And there are the different mappings that appear over here. And then there are multiple children. In this case, there's HER2 positive, HER2 negative breast cancer, there's breast sarcoma, lobular carcinoma, etc. Now on the right hand side of the screen, what we start to see is more of the ontological component. And this is where we start to introduce different questions that can help clinicians be able to answer whenever they're at the point of care. So a lot of clinicians are asking, what are the different clinical findings associated with the disease that I have in front of me? How do I actually screen for this? What is the diagnostic workup? What is the gold standard treatment for this? And what other diagnoses should I be thinking of and make sure that I rule out? So we do this with our knowledge graph. And essentially, we've extracted, we have over 16 different types of relationships that are maintained by our clinicians. And these are just some of them, like has physician specialty, has cause, clinical finding, diagnostic procedure, et cetera. And for each of the relationships that have been automatically extracted, we have a schema where we have validation for these different triples or associative relationships, so that the ranks are from 7 to 10. 10 means it's pathognomonic, really strong relationship. So for instance, if I am searching for what is the diagnostic workup for breast cancer, I'm going to see documents that retrieve mammography, fine needle biopsy, and these are all showing because the application is able to display anything that's been ranked at a 10 in the backend, and that is boosted for the user to be able to see that relevant information. This is just an example, again, of what that looks like on Clinical Key, one of our products. And Clinical Key has over 20 million content assets. It helps clinicians and students worldwide. Our taxonomy is used for autocomplete search function, faceted navigation. We can see related information on the side on this right pane. There's query refinement. And again, it's available in localized languages, which is very unique. Not very many, there's not very many products out there that actually have a localized version that has been manually curated in French, Spanish, Brazilian, Portuguese, and German. This is a bit of the size of our taxonomy. It also enables us to be able to extract content that is very noisy and unstructured. So we're able to mine semantic patterns from our taxonomies, improving the quality of our diverse data sets, and also improve automated annotation and search. And this really helps us with building clinical decision support tools. And it allows us to also break silos, connect different peoples, different content assets, improving discoverability and interoperability between products and content types. This is one use case of one of the projects that we've worked on. We have been able to extract symptoms, treatment, diagnostic procedures, drug relationships from medical content at scale. Over 4.2 million clinical relationships have been extracted. For the training set that we created a couple of years ago, we worked on a project that was basically building a clinical decision support system. So being able to, we extracted triple relationships of clinical findings and diseases, and had a training set of over 20,000 relationships validated by SMEs, subject matter experts. And so it's just to give you an example of what could be done. We've also worked on creating an algorithm that is able to pretty much navigate through different decision trees and be able to traverse the different nodes in the proper direction. So our model is able to identify what is the seed concept, or that first concept that is appearing at the top of the tree. And it can pretty much extract all the different pieces and components within the boxes and free text as well. And this can help, again, with being able to find answers quickly at the point of care by having a tool that can actually that can be used to query a disease or a condition or a clinical finding, whatever it is that the person is looking for. Over here, this is another example. I just want to show you what type of data science tools that we're building in combination with our domain expertise and localization expertise to improve search. And often we get the requirement comes to us where, can you help us align your taxonomy so that we can have improved discoverability for our clinicians in Germany? And in this example, what we did was we received 11 books, and essentially we created an aligner because not all of the books were available in XML. They were available in PDF as well. And so we used computer vision to be able to extract all the content within the appendices, abbreviations, indexes, and glossaries. And we sat down with SMEs to be able to write down a logic that can extract all of those nested concepts so that we can append them to the flat list. And then after doing so, we deduplicated the terms And then we ran code to see whether or not if the concepts were available in our knowledge graph. And then we indexed after machine translating it and having SMEs validated, we were able to ingest it into our knowledge graph so that it could be available in search. We then also made it available into translation automation shared service, which is one of the products that we manage that helps in building translation memory and improves interoperability across different types of products. This one is another example. I really like this one. It's exciting, I feel, because it's automated transcript generation and metadata tagging to link different products for medical students. So the request came to us. There's a bunch of different legacy videos, and these videos actually don't have any transcripts available. So we were asked, can we build a model that can create transcripts for each of these videos that don't have transcripts or metadata? And so that's what we did. We used speech-to-vec model, and then with this, we were able to take it a step further, and we developed a model, another layer on top of this that allowed us to extract key terms that were prioritized based on frequency count and on semantic category. And those terms were then used to interlink between different products. So in the case over here, we see in clinical key student, a student can type in hepatitis, and then what they see on the right pane, let me just move this over, is there are different foundational books in medicine that can be used to improve and like for their remediation and improve their learning. And then they can actually start to see different videos that could classify different types of hepatitis. Could be hepatitis A, B, C, D, or E, and then they could learn a bit more, improve their knowledge base. And we also were able to tag images. And this is more catered to students that are already like 3rd or 4th year medical students that are getting ready to transition to practice, where they have to start reviewing what does an ultrasound image of a hepatitis look like, what does it look like in a CT scan, anything to that effect. And then also just wanted to point it out over here is that we were able to connect content that is coming from books. So anything that's 2-dimensional images over here, like in the netters, we're able to connect it to our 3-dimensional images that are available in our product offerings, such as 3D for medical and complete anatomy, and then connect it to video content as well. So all of this is done through the models that we create. Over here, this is showing another request that had come in from one of our stakeholders. And this is working closely with the nursing team. And essentially what they wanted to do is they wanted to understand which of their students that were within the nursing programs that were at risk of not passing their NCLEX nursing board exam. And so what we did was we established a cohort of students. We looked at which exams that how they scored on their specialty exams and their exit exams. And we built a model that was able to predict with strong confidence what their pass rate or what their fail rate would be for the NCLEX exam. This was really helpful. The feedback that we got was that it was great because it provided actionable insight into how to improve remediation and how to improve the drilling for the different students so that they could increase their scores on their exams. This example is quite interesting as well. It's empowering clinicians and students to discover content. So essentially what we worked in collaboration with one of the other teams in Elsevier, the Science Direct team. And what we did was we created topic pages, which are essentially synoptic pages. They provide quick summaries on how do you diagnose, how do you treat, how do you do the workup for different types of diseases. We can see that part of the process involved being able to extract sentences from our medical corpus, where we use the BERT model to be able to classify, we identified different parts of speech, and then we were able to allocate the correct sentences with the definitions for those different terms that are appearing there with the taxonomy. We're also able to leverage our knowledge graph to identify different terms that are similar. So related terms, that's what we're seeing over here on the right. And these pages basically are indexable and searchable on Google, and they improve the physician and student search experience, and they're free. And this is what goes on a little bit behind the scenes. So each of the snippets were reviewed by our SMEs. The sentences were tokenized and prioritized and then graded, evaluated by the SMEs. We can see over here on how there was a scoring system. The SMEs, in the case of there being duplicate concepts, and SMEs had to be able to classify in a binary way which one was correct, which one was not. And then also for images, the same process. There were different snippets that were looked at, and then SMEs actually validated whether or not the images were correct. We looked at macroscopic images like this, different pathology images, as well as histology. What is the impact for these topic pages? We're essentially capturing over 23 million visits a month, 363,000 topic pages in 20 disciplines, and over 5.8 million journals are included in here. This is another example. This example is truly global. It's Ease of Doing Business, or EODB, Primary Care India. And essentially with this project, what we're doing is we're empowering ASHAs, which are they're essentially clinicians that are working in rural areas that are frontline. We're machine translating and validating it through the workflow using translation automation shared service to be able to support 6 different languages: Hindi, Telugu, Kannada, Marathi, Gujarati, and Assamese. And we're helping improve availability of the content so that these ASHAs can care for their patients. It's also standardizing and simplifying the process and having everything in one location. Another example that I want to present to you today is, or just talking about one of the main problems. So in most North American guidelines, they're published in journals, and many of the international guidelines are published on websites. There's a big portion of guidelines and journals that are not indexable. The guidelines are not indexable by region. So if we look in the United States, about 8% of those guidelines are not indexable. So it makes it very difficult to actually search. If we look at other countries, such as places in South America, such as Argentina, it's 84% are non-indexable. Middle East, it's very high. So one of the requests that came to us from the evidence-based practice team and the nursing team was to be able to take a list of different guidelines and to be able to create a bot that is able to surface the guidelines, be able to identify when there has been a dynamic change, when these 1,000 guidelines, if there's been a child page that has been added or removed, we're also tracking that as well. Anything that's been added appears in green, anything that's been removed appears in red. We're able to search by date. And the feedback we've gotten so far is that it's been very helpful, saves time. There's quite a bit of cost avoidance because we're taking care of it in-house. It saves around $16,000 a year just by doing that. And there's high precision on the output of this bot. This problem over here, now this is actually moving into more of the research domain and more in Josh and Anita Waard's case. I'm done presenting a bit of the health science use cases. Over here, this is a data science model that Josh and Anita are working on, where they're basically being able to create a multi-label classification modeling tool to identify different segments within the consort guidelines, within the methods and the abstract section, to help with automating the process so that anything that is reported is complete, it's transparent, and it has gone through a robust criteria. Right now, the way the process is, talking about the Lancet, it's very manual, time consuming. So this process, this model that Josh has developed will be able to automate the process. And Josh, if you want to add anything to this, please feel free to chime in.
I think you got it. Sounds good. Yeah, we're working on this. We're currently developing a labeled data set that will allow us to create a trained model that would automate this reviewing of consort compliant process. So yeah,
Perfect.
Back to you, Elia.
Thank you. Okay, we're also, one of our other teammates that's not here, Christy James, she's working on a model that is essentially being able to review the different credits. There's a taxonomy that came out in 2016 called the credit or contributor roles taxonomy. And essentially what it does is it helps to be able to identify all different parts of like authors, like the whatever is entered in the author contribution statements. It's not systemically used. Typically, if we look at the top part of the screen and unstructured statements from Science Direct, the content that's coming in is in natural language. There isn't a lot of structure. There are abbreviations. It's not very standard. And so part of the process that Christy has built has been to be able to develop a model that is able to help bibliometricians to understand how individual authors have contributed to a publication. So it essentially takes in all the different author IDs and the different statements to be able to identify what sort of contributions, especially when we're thinking about more junior data scientists or engineers, making sure that the impact is captured. Oftentimes we find that it's just the primary author or the last author is included in their contributions, and then people in the middle, it doesn't end up being visible or as visible. So that's that. And I also, Christy asked me to go ahead and share this, the ICSR, the International Center for the Study of Research Lab, which is empowering researchers in strategy, evaluation, and policy. If you want to go ahead and learn a little bit more about this, you can go to icsr.net. And essentially what it does is it helps researchers with gaining access. It's a cloud-based computational platform which allows researchers to analyze huge data sets, and it connects them with content from Elsevier, such as Scopus, Plumex, Metrics. And yeah, so you can sign up. The computational use is actually paid for, so it's free for you to use, and it can allow you to interact with large data sets. So research topics that can be of interest, open for Q&A. And this is just, I've listed just the 3 different types of things, but we're definitely open. There are, since we have such a large ecosystem of data scientists and teams, there's so much opportunity to really interact with us, work with us, and just have fun. So we work on often predictive modeling. We've not mentioned in the slides before, but we're also working on de-identifying data and working with data sets to be able to create some sort of predictive modeling to understand different trends in clinician behavior. Also, in the use cases could be in preparing a hospital for resources, like if there was all of a sudden more types of diseases or diagnoses by category, then the hospital can prepare with more clinicians to be rounding. Also advanced clinical decision support. We're also working on a project that is helping radiologists as well with being able to determine accuracy, improve the accuracy of the diagnosis based on radiographic imaging, and automating the clinical trial process. So being able to identify which clinical trials may be available for specific patients based on demographics, genomic data, clinical data, diagnostic workup, etc. So that's just a little bit of that. I do want to share with you a little bit about what are some of the different careers that are available that can shape the future for our customers. These are our open roles here in the United States. We also have many roles posted abroad. And if you want to check it out, it's at elsevier.com/about-careers. And then it will take you to other child pages where you can learn more. Special shout out to the team, to my team, and also to Anita and her team. This is who we are, and very diverse. We're on different continents, different skill sets, and it's a lot of fun. And that's it. If you want to contact us directly, please don't hesitate to send us an email. We're over here. I'm Elia, again, Elia Lima-Walton. There's Anita Waard, Josh Fisher, and Christy James. Questions?
Wonderful. Thank you so much. Hope
Thank you.
everybody can hear me. Oh, that's the wrong way volume is going. Thank you so much. This is great.
Thank you. And I finished right at 6.
No, magical timing.
Yeah.
Does anybody have questions? Please feel free to pop questions into the Q&A or the chat, into the chat feature. Yes. Please feel free to go ahead and start dropping questions in there. In the meantime, I can start asking, Anita or Josh, is there anything else we wanted to add before we started asking questions?
No, I'd love to know from all of you if this resonates. I'd love to hear back from folks if any or all of these topics are of interest, and just be very interested in that. Thanks.
Of course. So I'm sure we have plenty of students out here in the crowd. So if you all can drop into the chat, let us know if this resonates, what parts you found interesting, what parts really like piqued your interest. That would be great. Just feel free to drop it into the chat, and we'll start talking there and start grabbing information from there. While we wait to hear from our participants, which I highly encourage our students to participate. I do want to ask there are a few questions that we are able to ask our industry affiliates when they come speak to us during iCubes, that hopefully you'll be able to answer some questions, and we can find out a little bit more about well, we've talked a lot about roles, but your backgrounds and how we've prepared for being in a place that we are today. And it would be great to know and hear a little bit about what a day for a data scientist looks like. Oh, this is very informative. We have a question, particularly the research into predictive models to help improve accuracy in diagnosis. Thank you so much. Thank you so much for our participant for dropping that in.
Yes, thank you.
Great. That's great to hear that that was of interest and everything. We also found another comment. We have great presentation. I found it very impressive, the range of projects you're working on. How much of it, if any, do you make available to the public in terms of accessing some of the algorithms and methods you use?
Thank you. This was Paolo.
I believe, let me see. Paolo, yes, correct.
Okay, great. So we're actually working on availability of access. If anything is sensitive data, I think Anita can probably speak a little bit more, because you've been in the field in research with us on access to external clients, but typically everything is in-house. If we're collaborating with students, then yes, they interact with the data itself and with our data scientists and the team and the algorithms. But so Anita, please.
Available to the, well, I mean, it really depends. So really depending on the project. For instance, some of the work we do in collaboration with academic partners, and in that case usually there are publications about the algorithms, and the software is shared. Of course, some of the work that Elia was discussing does have to do with more with data sets where privacy issues may be pertinent. So then we have to make sure that we protect those. So it really depends if these are the overall methods. I think we do a lot of publishing and sharing with the community at large. But again, the data, there may be all sorts of issues, in particular if there is human subject data, of course, involved. So sorry to give such a vague answer, but I don't know if you have other examples, Elia, of specific projects and how you share.
No, I think that especially like with the radiology imaging that we're doing with the University of Tennessee, it's we have to be super careful just because of compliance and just on the intended use of a model, being sure that whatever applications are done downhill do not have any effect with the original data set. And so whenever we're talking about the patient data, it's definitely a little bit more difficult to share publicly.
Understandable. That's absolutely understandable. It's a difficult thing. And as Anita said, case by case basis. When you do work with our students in our capstone projects, though, I know that data sets are chosen so that our students are able to talk about their work afterwards and everything. So that's a good part. So if you do end up doing a capstone with Elsevier, they always propose wonderful projects for us students. If you're not in your final semester, if you're going to go up for your final semester, Elsevier proposes wonderful projects with us. They've been working with us for a few years, and we've always had great outcomes from them. And the data sets and the data that we're able to work with, everybody's always able to talk about their information afterwards. So so that's a good thing, right? It's a case by case basis. And this academic collaboration kind of way, students who work with you are able to talk afterwards. So that's good. Just plugging your capstone projects. for the semester. I always hear great feedback. So if anybody else wants to plug in a question, go ahead. But please feel free to comment or a question about anything. But we always are curious to hear about like what a day for a data scientist looks like. And I know all three of you have separate different roles, so it would be great to hear what those types of roles look like, to hear the different like angles that being engaged or working at Elsevier would look like.
Maybe that's a good question for Josh.
Yes, I would agree.
Sure.
Oh, yeah.
Yeah, sure. So I would say, I also got my master's in data science, and oftentimes we were given data sets that were nice and clean. And I think since joining Elsevier, I think there's a lot of work going on day to day into creating valuable data sets. So currently I've been working to create a gold standard for this consort project that Ellie has been talking about. So a lot of that is, sourcing the data from various Elsevier data sources. We use Databricks a lot, as well as a number of other AWS related, repositories. So actually capturing that data, transforming it, getting into the right format, so it can be used for, pipelines later on for, down the road and as the project develops. These projects take a long time, so there's a lot of research. We are a research-based company, so researching, what the best kind of models and, what is already out there, what people across the company have already done. So really taking your time to understand the problem and ways to solve it, and, not always reinventing the wheel, but we do create a lot of in-house tools itself if need be. So a lot goes on day to day. That's my general overview.
Awesome. I think that's really insightful to just hear your perspective. For me, it's going to be a little bit different. My team I do have several data scientists on my team, and I'd say like for me, it's more of setting strategic direction for the team, hearing what that problem is, being able to internalize it and figure out what sort of a technical solution could be made. Again, like Josh mentioned, a lot of the work goes really in receiving the data, normalizing it, putting it into a nice standardized format, and then developing your model, determining which model to be used and refining it, working closely with other team members, such as the SMEs, to help refine the model and all of that. And it's just, yeah, a lot of fun.
Yeah, and I just want to add, I think a lot of time, Elsevier is a very big organization. We're part of an even bigger organization. So I think one thing that we're fairly good at is creating communications between different departments. So there's a plus and a minus. There are many, many different groups, and there are at the moment, I think we're at 250 data scientists across the company. So there are often training sessions, there are talks being given, mostly virtually, but sometimes in person, in the different offices. There are many active Slack channels, there are projects, there are occasionally hackathons and things that happen. So I think partly we have sort of a vibrant research culture. There are certainly people who publish papers, who present at conferences and such. And partly it's also being part of a large organization. So what Josh and I have spent a ton of time is all the different people that our projects impinge on, and talking and hearing that there's yet another group who's doing something that is relevant to what we're doing. So you certainly spend a lot of time communicating, hearing what other groups are doing, telling other groups about what you're doing. We generally give the same talk about our work, 3 or 4 or 5 times in different forums to find out who all it impinges. So I think there's a lot of communication for sure. and that's certainly a part of it. And I just want to add, Elsevier is very much an employer focused on having healthy work-life balances and such. So I just want to throw that in there. It's not directly what you're asking, yep. But we certainly believe that you need to have, so we're pretty flexible with when you work, when you start, when you end, that kind of thing. I mean, I think everybody's pretty motivated It's not a punch the clock kind of a culture, I would say. I think people definitely have the flexibility to within bounds. Obviously, when there's meetings, it's helpful to be on the meetings, but to really be fairly flexible to fit around whatever matters else in your life. I just wanted to put that out there. I think that's
it's an amazing company to work for. Like, this is my first real industry long-term job, and I love it. I've been here 7 years. The company really looks into investing in its employees with different signature programs like mentoring or connecting you with somebody that's higher up in the business to show you whatever it is that you're interested in. It could be that maybe you're a data scientist, but you're interested in learning a little bit more about medicine or about risk management or legal, whatever it is. There are programs available to improve also diversity and cultural type experiences. Yeah, there's so many different things that are really cool. So like being able to work from a different country for a month, for example, or 2 months, if your home is in a different country, then that's an option too.
Oh, that's wonderful.
Yeah.
And as an industry affiliate, let me just say, it's wonderful to work with Elsevier. It's great to work with Elsevier. I can feel it radiates the like good work culture kind of feeling that I get from whenever I speak to anyone from Elsevier. It's like you can feel that. So I highly encourage everyone to look into the roles that are available at Elsevier. And actually, this is a great segue, because some participants asked, are you going to recruit data science summer interns? If so, are you at our career fair that's happening on Friday? I'm not sure. I'll double check. But do you know if you're
I'm not, but I would love for us to have an intern or two, or that would be amazing.
Oh, that's
Anita.
awesome.
Yes, we are not at the career fair. Is that an in-person fair, or is there also a virtual?
It is an in-person fair. So, but
Okay.
Since you are an industry affiliate, and students, please pay attention. If you send us any position that you might have, if you have an internship position, we will send it directly to our students, and our students will be able to either apply, or we can put together a resume book, and our students would be able to directly apply with you. So and also, everybody, if you're interested, please feel free to email me, jr3056, so that I can make sure you're not missed when we put together resumes or anything. So we make sure everything that's appropriate. But the career fair is in person. It's our first time back in person since COVID. But this is why these iCubes are so informative, and we're able to do information sessions. And as an industry affiliate, we will take care of getting to our students for you. Yeah.
That's great.
Yeah, I would love to connect afterwards to discuss, maybe with Anita as well, just on like cost models and how we can go about starting something.
Awesome. Yes.
And Jessica, I don't know if we have the in-person career details. We do have 2 members of Elsevier Labs who are based in New York, Corey Harper and Jessica Cox. I think you may have been in touch with previously. There might be a chance that they could possibly join. If
they are, come on down.
Okay, it's at Columbia, I would think. Yes,
it's at Columbia, and our students actually just started signing up today, so they'll be able to we definitely have time. Absolutely.
Okay.
At what time is it?
It's from, let me see. Oh, it's actually the 14th. I keep on saying today, but it's not. It's the 14th, and it's from 10 a.m. to 3 p.m.
Okay.
Here at Faculty House here on campus. And our students just started signing up, and we could definitely make something work. And yeah, I'll send over the details. And then if I don't have the names of the people who are local, we'll sort something out. Yeah.
Okay. Wonderful. Thank you.
14th. Okay. That's good to know. Thank you.
Yeah. Yes, of course, not a problem. Oh, that's exciting. So thank you, students, I believe Yihan Chen for asking this question. It sparked a make sure to email me if you're interested. How about diversity in the company? I'm being asked about privately, so I won't say the person's name. Could you speak a little bit about diversity in Elsevier? I know Elia spoke to this a little bit when we had the photos up and everything, and talking about even diversity of location and origin, and I would love to hear a little bit more about
Do you want
All of us at once?
Go ahead. Go ahead.
I don't want to pinpoint whoever feels good about.
So yeah, I think like that one slide that I had showing all the different geographic locations, I feel like it's definitely quite diverse. On my team itself, we have people from so many different countries represented, and it's great to have the diversity, not just in talent or skill set, but also in culture. It's a lot of fun whenever we have our team meetings and we talk about what's your favorite dessert. And so just hearing the differences is really interesting, and approach to how you would tackle different problems. And so, yeah, I'd say it's quite diverse.
I say we're actually, I think we got an award not long ago. Here's a page that's about our inclusion and diversity. We've we've gotten best company global culture, best CEO for diversity. It's quite amazing. I joined Elsevier in 1988, before any of you were probably born. And it's always been an interesting company to work for. But I have to say, since our new CEO, Kumsal Bayezid, has become CEO, the corporate culture has just become really, really fantastically focused on diversity and inclusion. She actually gives some very, very good talks about this. She says, I care greatly about diversity because the more diverse our teams are, the better the company will be. The company is more creative, stronger, more interesting, etc. And for her, inclusion is a result of diversity. She said, we really need diversity in every single aspect, in terms of gender identity, etc., age, ethnicity, backgrounds, every single aspect. There's a great effort to make sure that we have a diverse workforce, and people are supported in whatever their background is, whatever their needs are. Just a tiny example. We have 2 floating holidays that can be any form of religion that you might want. It used to be that there was sort of a more standard set of holidays that we had days off, and it was like, well, maybe you want Yom Kippur off, which is today, or maybe you like Diwali off, or maybe you would just like to celebrate the solstice. That's just a tiny example, but we have very active employee resource groups. So for instance, I'm active in one that is the Elsevier Pride group. I have a transgender son, and I have a program for people with transgender kids inside Elsevier. We, just as an example, we have a very active Pride group, in fact. I think it's also gotten all kinds of awards. Also, I think in terms of diversity, in terms of personal situations, so as I mentioned, if there are situations where you are a caretaker, whether it be of children or elderly people or friends, relationships, I think there's a huge amount of flexibility, both in principle and in practice, to deal with whatever you need to spend your time on. People take sabbaticals on fairly regular bases. There's a very active volunteering culture that's mostly around the offices, but also in the home-based employees get time off to volunteer. If you want to volunteer locally, that's really supported as well. So I'd say I wouldn't have said this 10 years ago, but right now it is really quite an amazing company in terms of diversity and actively recruiting a very, very diverse workforce.
That is wonderful to hear. That's exciting. All those initiatives too. Seems like there's space to create space, and that's always a good dynamic to have in any workplace where there's a sense of openness to evolving, which is awesome.
Mm-hmm. Yeah, one thing that I think that I would like to add to what Anita said was also for disabilities, like you were saying, caring for children or parents. There's also a focus on having a psychological safe space and helping those that may need some more help, and different resources if there is a family member that has a disability, for example.
It's wonderful.
It's a great company. Yeah.
I love that. It's wonderful. It's interesting work, and there's a good culture going on. It's an amazing culture. More than good, amazing. It sounds amazing. That's wonderful. Thank you so much for these questions, everybody. I'm going to go ahead and ask the next one, but always feel free to drop more questions into the chat. Can you tell us? I know, Elia, you're an MD, but it would be great to hear from Josh, who's a data scientist currently, and also Anita, who I know you've been with Elsevier for a little bit, a little while. But but if you would tell us a little bit about your career and what brought you to your current role as data scientist or working with data science at Elsevier.
Sure. Yeah, I'll go first. So my background's primarily in biomedical research. So specifically radiology, using MRIs to study the brain and spinal cord. But in my position here in Philadelphia, I was, getting more into the data science aspects to my job. So I, started learning to code, building, different models, statistical analysis. So I really identified that as a career path that I wanted to pursue further. So I got my master's in data science, and kind of circled back. I came across Anita in her position on her team, and I thought it was a great intersection of research, in which most of my career has been spent in, but also the focus on data science. So I joined. I think it's only been about 7 months now I've been with the company. So relatively new, but I've had a great experience so far as a new data scientist. Yeah.
I'm sure Anita's a wonderful mentor.
Yes, she is like the lifeblood of the company, I would say. She knows everybody, great networker, and understanding of the business.
Well, I can briefly say, like I said, I've been at here longer than many people have, been around on the planet. And I don't, people ask me, why are you still at Elsevier? Which is one way of putting it. Or how have they not fired you? That's another question. But my background is in physics, and I am sort of, I guess, I was interested in science publishing in the way that maybe somebody who loves rock and roll but can't sing, becomes a manager, kind of a thing. Like, I always loved promoting science and improving science, but I was not great as a physicist myself. But I realized I love language and I loved editing papers. So I first joined Elsevier out of college with a master's degree in experimental physics, to edit journals in physics. Then, this is a long time ago, the Berlin Wall fell and the internet came, and both of those affected. The fact that the wall fell meant that the funding in solid state physics went down, but the fact that the internet came meant that we had to rethink, how does scholarly communication even happen? So for me, since about the mid-90s, I've been very interested in this question of, how can we improve the way that scientists communicate, and how can we improve science by improving the way that scientists communicate? So I've done a lot of work. I've been in very many different departments around the company, but for me, the focus has always been on starting with improving scholarly communication. Secondly, how do you involve technologies like AI, like semantic web technologies way back when, search, interfaces, visualization, all these techniques to improve science communication. And for me, the third big pillar is the community. So how do you do that together with the scientific community? And actually, part of my job is to organize workshops, seminars that are academic workshops and seminars that have to do with scholarly document processing. I'll give a little plug for a meeting we have in 2 weeks at Coling. So this is an NLP workshop on scholarly document processing, really taking processing scientific texts as a field of study within computer science. So for me, the passion has been helping scientists communicate utilizing information technologies. That's really where I come from. And Elia, to you.
Me. So my journey actually started before Elsevier. I studied international studies and Spanish literature. And I ended up just really feeling the calling to study medicine. I studied medicine, but I felt the real need to not just focus on one patient at a time, instead try to do a more global approach by working at Elsevier. So being able to find opportunities to develop solutions that are making an impact at scale really motivates me. And so that's me. Yeah.
That's wonderful. Thank you so much. Thank you to all three for answering that. That's awesome. I think we have time for another. This is a question I love to ask, and I think is always an interesting one for our students. What skill set, or what skill, not skill set, but if you want to just point out your top skill that our students, that you would recommend they leave this program with, what would that be? Sorry, my question, the way I presented it was a little bit convoluted, but what skill would you tell our students, like, make sure that when you leave, you have this under your belt? It could be a soft skill or it could be a technical skill. Happy to hear.
I would say, no, you're not going to know everything. So being able to apply and learn new skills is really valuable, because at Elsevier, it's you're very encouraged to develop yourself. So taking the time to research new techniques, new tools, we have a lot of resources available. So just having that interest to learn those new skills.
Don't be afraid to fail, and to just keep at it and think outside of the box, kind of a thing. So just because there's so many different avenues to get to the answer, it's just try your own type. Yeah.
Absolutely. I completely agree with both of those. I guess I would add to that, keep asking the hard questions, and don't prejudge any question you ask. If you're saying, you never need to preface it with, this may be a stupid question, or like, the people have already thought of that. That whole part of the sentence you can say in your head, but just leave it out. Just start with your question, because probably other people are asking the same question, and probably it's a really good question to ask. So don't be afraid to keep asking questions of anything, I think. And if I'm thinking of, like, Josh coming in, 7 months ago, which is pretty incredible, actually, Josh, it's only been so short, but just the fact that you came straight from an environment where you were working with data, and you approached everything from where you stood, from where you came in, that's just been so helpful for me. So the skills that you guys have, and that you currently have, and what you're working on, start from where you are. Don't worry. Don't think that you should be somewhere else. Be open to, absolutely, to learning, but start with the questions that you yourself really want to see answered, and those are probably super helpful for any company, but certainly for Elsevier to have answered. So
that is wonderful. Thank you. That's a great. Have the space for questions, innovations, to put out new ideas. That's a great place to be. So I just want to thank everybody for their time today. Thank you so much for joining us. Thank you so much to Elsevier Industry Affiliate for coming and giving this wonderful talk and having this wonderful discussion with us. We hope to have you back again very soon. We'll probably see you at the end of the semester for Capstone readouts for the poster sessions. We'll probably do a virtual and in-person kind of hybrid thing. So we'll look forward to that. And we're getting lots of thank yous from our students as well. And thank you, everybody. And we hope to see you again soon.
thanks so much.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.
Bye-bye.